Hello everyone, welcome back to my YouTube channel SummarizedAI. This video is packed with powerful LangGraph concepts and you will learn more than you expect as we are going to talk about multi-path AI application using LangGraph. This program is all about stateful AI workflow that intelligently routes user queries using LangGraph conditional edge to either a PGVector-powered RAG application, a calculator, or a clarification path, or a direct path for just and the flow. Let's break this flow down and make it easy to understand. Suppose a user asks a question, the graph first stores this question in the shared state so that all later nodes in the flow can access it whenever needed. Then the decide search node comes into play, reads question from the shared state, and decides which path or flow to follow based on the user's query. It saves its output in the shared state as RAG or PGVector or clarify, so the next calling step node can access it. For example, if the user asks, what is RAG? The graph will route the request to the PGVector node. Internally, the PGVector node calls the PGVector tool node, which in turn communicates with the PGVector database to fetch relevant information once the data is retrieved. A tool node in LangGraph is a special helper that the graph can call to do tasks and AI cannot do on its own, like fetching data, running code, or accessing a database. It takes input from the task and gives back the result so other node can use it. Now the PG vector answer node processes it and returns the final response to the end user. On the other hand, if the user asks something like 5 plus 2 or 5 into 2 or any other calculation, this time the calculator node performs the calculation and return the calculated response to the end user using calculator answer node. Suppose this time we ask a question that is unclear or ambiguous. The graph will route it to the clarify node, which asks the user for more details or clarification and end the flow. Now, let's go to the Visual Studio and see the real-time implementation. Let's create a file, multipath.py. Now, before we start our implementation, we require some of the third-party library to be available in our local. So let's go ahead and install those libraries. So the very first library we require is langchain underscore OpenAI, as we are going to use this langchain underscore OpenAI to create the vector embeddings. Now, the second one we require is langchain underscore text underscore splitter, which will allow us to split the text and create chunks with the overlap. We will discuss about the splitters in detail in this video. Proceed further, we require the Postgres where we are going to store our embedding. So this is going to be our vector database. Now we require one more library, which is nothing but the LangGraph. So we can say LangGraph. So now we have list of all the libraries which we are going to consume as part of our application. So to install these libraries in our local, either we can go to the command prompt or we can go to the Visual Studio's terminal or in your IDE's terminal, copy paste these libraries command one by one. So I'm saying pip install langchain underscore OpenAI. So it got installed. Okay. Now after this, I'm going similarly for langchain underscore test underscore splitters. Now, if you see, I'm getting this message requirement already satisfied, which means I'm already having these libraries installed in my local. So similar to this, we can run these two commands also, and we'll be able to install all these four libraries in our local. Great. Now let's go ahead because we have the libraries installed. We can make some imports. So from langchain underscore text underscore splitters, import recursive text splitter. Great. Now from langchain underscore OpenAI, import OpenAI embeddings, which will allow us to create the embeddings. And the second one is the chat OpenAI. Now, after this, we require to have Postgres, as we are going to use the Postgres database to store our vector embeddings. So let's go ahead and import PG vector here. Now we require one more, which is LangGraph. So LangGraph.graph import state graph and and state. We have the required imports with us. Now, other than the LangChain and LangGraph, we require some additional modules to be available. So from typing import typed dictionary, comma, list. Now import OS. We have all the imports with us, and I'm going to explain you each and every imports what we are importing here. Cool. So let's proceed further. As you know, we are going to work with OpenAI. We will require the OpenAI key. So here I'm going to say os.environ, and here just say OpenAI underscore API underscore key. I have already created a video how to generate the API key. You can go ahead and check out that video. You will be easily able to generate the API key. So I'm already having this API key with me. I'm going to copy paste that API key. Now what we require, the second thing is the database connection with the PG vector. So that detail we require. So here we are going to say database underscore URL equals to PostgreSQL and then colon your username using which you get login and the password. So in my case, the username is Postgres and the password is admin. Great. Now at the rate, I'm going to use my local host. Okay. And local host on the port 5432. Now in this Postgres PG vector database, I am having by default or out of the box Postgres as a database, which we are going to use. Once we have the database URL, we can also provide the collection name, and collection name is nothing but the virtual table name. So I'm going to explain you each and everything where we are going to consume this collection name. So don't worry about that. Let's proceed further. So I'm going to provide my collection name as LangGraph underscore docs. Okay. Now we require to have a LLM, and LLM we are going to get it from the chat OpenAI. And here you just have to provide the temperature if required. So I'm going to just say 0.4. Okay. Now after this, we are going to create the shared state. So I hope you remember when we were asking a question, that question was getting saved into the shared state, and the step one output, step two output, everything was saving in the shared state. So that shared state we are going to create. So for that, let's say class reg state, okay? And inside it, we are going to provide the type dictionary because it is going to be a key value pair. So the very first one we require is the question, which is of type string. Now we are going to do the search type. Now the search type is going to be the RAG, clarified, or calculator, or direct. So these are the values we are going to save as part of the search type. So it is going to be the type of string. Now after that, we are going to have the documents, which is list of string. Okay. Now after this, we are going to save the tool result also. If you are getting any result out of the tool, we are going to save as part of the tool result. Now in last, when we are going to return the final response or the answer to the end user, we are going to save that as part of the answer property. So this is also going to be the str. Now our state is ready. Now what we are going to do, we are going to cover the very first scenario where we supposed to have a PG vector node, and that PG vector node will call the PG vector tool, and that tool will call the database to get or set the data. So let's go ahead, and for that we require a raw document. So this is a string what I'm going to use. But point to be noted here, I'm just using the string of 2 lines. We might have the very long string of like 1,000 lines or 2,000 lines. Okay, but this is just for the sample purpose or the tutorial purpose. I'm taking only 2 lines of data. So now, as we know, we have this raw documents available, and inside raw documents we have multiple string. Now string can be of any length. Okay, it can be like 1,000, 1,000, a very long paragraph also. So to divide that paragraph or to create the chunks of that particular paragraph, we are going to use recursive character text splitter. Okay, now this recursive character text splitter will create the chunk of size 50. Okay, So it will create the size of 50. And apart from this, we are going to have chunk underscore overlap is equals to 50. Now, what is this chunk size and what is this overlap? For example, I have this string here. Okay. Now in this string, it will divide the complete string. So this recursive character text splitter is going to divide this string in the 50 character. Okay. And this chunk overlap shows the part which is going to be overlapped. So for example, I have this particular string here. Now, for example, this particular string is having a 50 characters still here. Okay. Now this is my first chunk and the second chunk is going to be this one. But what we are saying, you have to overlap. Okay. Which means you have to overlap 10 characters from here to the next string. Okay. Now, point to be noted why we are doing this because our LLM for not to lose the context. And for that, we are just overlapping some part of the string into the second chunk. And we do the same thing for the subsequent chunks also. Great. Now here I have just given an example of 50 and 10. So chunk size 50 and the overlap is 10. So in the real world, what you are going to do, you are going to create the chunk size of 500 and you are going to overlap 100 characters. Okay. Why? Because this 100 characters will provide a good context to our LLM. If we are going to say 10 or 15, it will not provide much context because here, if you see, we have just said stateful AI workflow. No, if we say framework for building stateful AI workflow, this makes a sense and this will provide more context to our LLM. If we provide only stateful AI workflow, then our LLM will not be able to understand. So this is how we use the recursive character text splitter. Great. Now we require an embedding model. So embedding model will help us to create the embeddings. And as discussed, embeddings are nothing but the numbers separated by comma. Okay. I will show you what embeddings, how it looks and how it works. I will explain you each and everything. Let's say embedding underscore model. So we require a model to create embeddings. So here we are going to say OpenAI embeddings. And here you just have to provide the model name, which will help us to create the embeddings. So here we are going to use text embeddings hyphen 3 hyphen small. Great. So this is the model we are going to use to create the embeddings. So now we are going to loop through this raw documents and create chunks. And for every chunk, we are going to create the embeddings. So let's do that. So we can say here for doc in raw documents. Okay. And then next you can say splitter dot split text, provide your doc here. So it will allow you to create the chunk. Now we have to store this chunk somewhere. So this is the list. So which means we are going to get the list of chunk. So here let's create the list. Okay. And below you can say text dot extend and just store all the chunk into this list. Great. Now we have all chunk here. Now what we have to do, we have to store chunk into our database, PG vector database. So for that, we are going to create PG vector store. So let's say PG vector underscore store equals to PG vector. Okay. So where and how we are going to store the chunk, we are going to store with the help of PG vector. So here you just provide the connection detail. Okay. So connection equal to, you can say database URL. Now the second one is embedding model we require. So that we have already created. Now we require the collection name, which is going to be the collection underscore name. Okay. So now we have the complete detail of PG vector database. Now we can use this PG vector underscore to add our text into the PG vector database. Great. It should be 1A and just pass your text here. Great. Now, once you have this, okay, you can just provide the print statement here and simply say documents successfully stored in PG vector. Let me clear my console, okay, and just execute this piece of code. And this piece of code will allow us to create the chunks. And for every chunk, we are creating the embeddings, and every embedding we are going to store in our PG vector database. And let me show you my PG vector database before we proceed further. So in my PG vector database, here I have only 3 tables, which are not part of the current tutorial. Okay. So as soon as I will execute my piece of code, it will create new tables. So let's see that. So as you can see, our code successfully got executed. Let's go back to our PG vector database and see what it created for us. So let's refresh this tables. So here, if you see, 2 more tables got created. The very first is langchain underscore pg underscore collection, and the second one is langchain underscore pg underscore embedding. So let's see first what we have in collection table. So in collection table, we have the detail of collection. Okay, so we provided the collection name here. If you remember, LangGraph underscore dogs here. Okay, so it created that particular virtual collection name here, and it provided the UUID for this particular collection name, the unique ID. Okay. Now, if I look for the embeddings, now you will notice here we have a unique ID for every embedding. Okay, and this is the embedding text. And this one, you see the collection ID. This is nothing but the ID coming from collection table. This represents the data from this ID is from LangGraph underscore docs collection. So you can say our embedding got created. So if I move it further here, you see we got our embeddings created. So embeddings we said like nothing is but the numbers separate by comma. Now if I copy this number, okay, and go back to my Visual Studio and just open a new file, you see here if I copy this comma, you can see we have 1536 numbers. Okay, 1535 comma and 1536 numbers got created with the help of this model, the small model. Okay, now if we use the large model, the numbers is going to be more. Okay, and if we have more number, it will provide more accuracy in terms of result. But if we have less numbers, it will provide the less accuracy. Now this is how we create chunks, and from chunks we create the vector embeddings. Okay. Now we have our vector embeddings us, so we can go ahead and comment this line because the embeddings already got created and we don't want to create this embedding again and again. Now what we want is we wish to fetch the data. Okay. And for that, we require a retriever. We can say pg vector dot as retriever. And here you just provide one argument, which is search underscore k works. Okay. Now this particular argument will help us to get the number of results. So for example, if I provide a value of 2 here, which this means when we are going to make a query to our database, it will provide 2 results which are more relevant. Okay. Now how this relevancy works, okay, and how this scoring works, you can go ahead and check my earlier video. I have explained all this in very detail there. As soon as we say pg vector store dot as retriever, it will provide us the results, 2 results. Okay, but I want only one, so I'm just going to say one. It is the time to store our response in one of the variable. We can say retriever. Okay, retriever equals to pg vector store dot as retriever. Great. Now we require to have a tool which is nothing but a Python function which allow us to retrieve the results based on the query. So we can say define pg vector underscore tool and just pass your query here, which is of type string. And what we are expecting in the return, we are expecting the list of results. So we can say here list and str. Great, done. Now here we can say docs equal to retriever dot get underscore relevant documents. Okay. Now here you just pass your query. Okay. Now once you have this docs, we can return this doc. So doc dot page underscore content for doc in docs. So we are going to get an object, and in that object we are going to have multiple attributes. But what we are looking for is the page contents. So that's where we are returning the list of page content inside the docs. Okay. Now to access this PG vector tool, you remember we require a PG vector node. So let's go ahead and create that PG vector node. Let me go back and show it to you. So what we discussed earlier, we are going to have this PG vector node, and this PG vector node will call the PG vector tool, and that is going to call the database. We have the PG vector underscore tool. Now what we require is the PG vector underscore node. Great. Now after this node, we require the PG vector underscore answer to return this answer to the end user. Good. So let's go back to our Visual Studio and define the PG vector underscore node. And here, this will also require the state. State will always be there in any case because it requires the data from the shared state, and it will save the data also. Now here, what we are going to say, we are going to say state documents equals to PG vector underscore tool, and just provide your query here. So for that, you can say state and the square bracket, and the square bracket you can say question. Okay. So because we have provided a question here, now it will allow us to have documents and return these documents as part of the state. Great. Now we have this particular flow available, PG vector and PG vector tool. Now let's create the answer node also to return the answer to the end user. So for that, let's go back to the Visual Studio, and here you can say define PG vector underscore answer underscore node. And here again you require the state, which is RAG state. Now here you can say context equals to skip character and then dot join and here just provide state and the documents. Okay. And after this you can just generate a prompt. So in the prompt you can say prompt equals to, just provide the text, answer the question using only the context below. Great. Now here you just provide the context. That's it. We are done. So here you can say context. Okay. Now after this, you can invoke your LLM. You can say LLM dot invoke. Okay. And it will require your prompt. So just provide your prompt. And once you get the response, you can say dot content dot lowercase. Okay. And store this in state answer. Okay. And then return the state. Simple. So what we did here, we got the documents. Okay, so as you know, we have stored our answer in the document. We are accessing this documents here. And from this, we are creating a context and we are asking our LLM to create the human readable answer using the NLP and return it to the end user. Great. Now this is one of the flow. So for math, we require a calculator node, and calculator node is going to call the calculator tool, which will evaluate the expression. And we will store this answer in the shared state, and we are going to access that shared state answer in the calculator answer and return to the end user. So let's do that. Let's first create the calculator tool node, what we did earlier for the PG vector. So here you can say calculator underscore tool. Okay. And here we require the expression. So str and return the str. That's it. And here we are going to return string after evaluating an expression. So evaluate expression. Now we require a calculator node to access this calculator tool. So let's go ahead and define calculator underscore node. And here you can pass the state, which is nothing but our RAG state. Okay. Now here you are going to get the result from that calculator tool. And that particular result we are going to store with the name of tool underscore result property. Okay. Now here you can simply call calculator underscore tool and pass your question. So you can say state and in the square bracket question. So here you got the question from the state and you pass that question to the calculator tool. Calculator tool will evaluate the expression and it will return the response. Okay, so for example, if you have 5 plus 2, it will return the 7. So if you got the 7 in response, we are going to store the same response in the tool result property in our shared state. Okay, now return this shared state. Okay, updated state. Now we require one more node, which is this calculate answer node, which will allow us to share the result with the end user. So let's go ahead and create calculator underscore answer underscore node. We are just going to pass the state and it is rag state again. And here you just update the answer property of your shared state. So state answer equals to, just format it and say calculation result. And here you just say state, inside it you just say tool underscore result. Okay, so this way you will be getting your answer. So return the updated state. So now we have this flow ready and this flow ready. Now we require this clarify. Okay, so for that, what we are going to do, we are just going to define a clarify node, clarify underscore node. Okay, because we are just going to have only one node. It will also take the state. Okay, and in the answer, what we are going to say, we are going to say, please provide more details so I can help accurately. It will update the answer. And as we know, like return the state at the end of the day. So now we are only remaining with the decide search and the start where we are going to provide the query. So let's first create this decision logic. So for that, we can say define, and here you just pass decide, give a name to a function decide underscore search, and here you just pass the state and rag state. Okay, and return the updated rag state. Q equal to state, and you have to get your question. Okay, and once you get the question, convert it into a lowercase. Okay, now what we require here is we require the conditions, but before that our default search is going to be the direct. So we are going to say search type equals to direct. So we are going to write some conditions to define which flow to get call. So we can say here if any, then the bracket operator in query for operator in this. Okay, if we have any operator available in our question, plus, minus, multiplication, division. So in this case, we are going to have our search type as math. Okay, now let's write the second condition, elif. Then here you can say any if word in our query or question for word in LangGraph, comma rag, comma vector. Okay, then we have to call rag. So our search type is going to be rag here. Okay, now the another condition is for clarify. So here we can say elif if length of our query, okay, dot split is less than 3. Our search type is going to be clarify. Now we can return this updated state here. Now our decision logic is ready. So now we will create a router to route our flow, define router. Okay, and here we are simply saying state and then drag state, just return the state here. That's it. This is what it is looking for. And this is the router which will allow us to help to go in particular flow. So right now we have created this, we have created this, we have created calculator node, we have created decision search, we have created clarify node. Now we have to combine all this. and we have to define the flow, which will get call after which flow, and also what sequence it is going to follow. So for that, we require to create this kind of graph where we are going to have the nodes and the edges in between the nodes so that we can identify the flow. So for that, let's first create the graph. And to create a graph, we can use state graph. And state graph will require the state, because this particular state graph, every node of that graph require the state. So that's where we pass this particular state here. Now you can say graph equal to state graph, okay? And let's add all the nodes inside this graph. So whatever nodes we are having here, let's add all the nodes. So the very first node we are going to add is decide underscore search, and it will say decide underscore search. Now after that, we require to have graph.node, add node, then we require calculator, okay? And calculator is nothing but calculator node, okay? And after this calculator node, we also require to have the calculator answer node. Okay, so here we can say calculator answer node. Now after this, we have some nodes related to the PG vector also. So here we are going to say PG vector and just pass PG vector node. And similar to PG vector node, we require to have the answer node. So here we can say PG vector underscore answer node. Okay, so now we have this available, this, and this. We require the clarify node. So for that, we can say here graph dot add node, and here you just provide clarify, okay, and just say clarify node. Now we have all the nodes available, okay, and we wish to have one entry point from where our code will get entry, okay, and there I'm going to write graph graph dot set entry point, and entry point is going to be the decide underscore search, which means as soon as we provide the question, this will be the first one from where the code will get entry, and this will decide where to go. Now we have placed all the nodes on the graph. Now what we require is edges, the connection between the nodes. So for that, let's create the edges. We can say graph dot add edge. Okay. As you know, we require one edge in between PG vector node and PG vector answer. Okay. So let's do that. So we can say PG vector to PG vector answer. Okay. And then as we know, after PG vector answer, it is going to be AND. So here you just say from PG vector answer to AND. And this is what we have imported here as AND. Okay. Now this is we have for PG vector. Similar thing we require for the calculator. Okay. So here we can say calculator node. Okay. It will go to the calculator answer. Okay. And from calculator answer, it is going to be AND. Great. Now we require one more, which is like from clarify to AND. Okay. So let's do that. We can say graph dot add edge, and here we are going to say clarify comma AND. Now we have all the relations available. We have all the nodes. We have all the edges in between the node. The next thing what we require here is the conditional edges. Okay, so this one. So how it will decide like you have to go here or here or here. So for that, we are going to say graph dot add conditional edges. And in this conditional edges, as we know, our first node, it is going to be decide underscore search. Okay, so the flow will get start from here. Now the next comes the router. The router what we have created here. Okay, and this router is going to return the search type. The search type is going to be the RAG, math, clarify, and direct. Okay, so here we can say simply router comma this. Okay, and now here what we are going to do, we are going to say if we got math. Okay, if we got math, then you have to call calculator. Okay, and then if you got RAG, then you have to call PG vector. Okay, similar to this, if you got clarify in the response, then you need to have a clarify node to get call. Now, in last, if you got the direct, okay, then you have to end the flow simply. Don't do anything. Okay, so now everything is available with us. So let me tell you one more time this particular flow. So here, whatever router is going to return. Okay, so for example, once this will get call, this particular function will decide what the search is going to be. Okay, and here, oh, sorry, I think I did not keep anything in the state. So I have to update the state here. So here we are going to say state and then search underscore type, which is equals to search type. Okay. So once this decides, so let me go again. So once our execution gets start, the very first function it is going to call is the decide search. And inside decide search, we are just updating our state with the type of node it is going to call. Okay. So for example, if it selected math, okay. So in this case, the router will come in picture. So router knows what is it is looking for. It is looking for search type. So this will return math, for example. Then it will look for the mapping of math here. Okay. So math is tagged to calculator. Then it will call the calculator. So this is how the flow is working in LangGraph. Now everything is ready with us. We can go ahead and compile our graph. Okay. So graph dot compile. Okay. Which means we are just initializing the graph. Okay. The complete graph. And here you can say app equal to graph dot compile. Okay. Now let's invoke this graph. You can invoke using app.invoke, and inside this you are going to pass your attributes. So the attributes, what it is looking for here is the question, search type, documents, and all those things. So here we are going to pass the question as what is LangGraph. Okay, and then the next thing what we require is the documents, which is going to be empty. Okay, and after this we require the which is going to be empty. And after this, we require tool underscore result. And this is also going to be empty. Okay, we are initializing it with empty. Now we require answer, which is also going to be the empty at the beginning. So we got our graph invocation. Store this particular thing into the result as a variable. Okay. Now let's print out the output. You can say print result. And as you know, inside result, we have this answer property or the field we are looking for. Okay, for the final answer. Let's go ahead and execute this piece of code. It is giving an error, get relevant documents. It should be this. Okay, let me go back and check. It is saying dot get relevant documents. So when we are going with the get relevant documents, we require to have a variable which is run manager. It is the value is going to be none. Clear the console and re-execute this code. Now you can see we got the output. LangGraph is a framework for building stateful AI. Good. And this is the same thing we have embedded in our vector database. So if you see here, LangGraph is a framework for building stateful AI. Now how this flow worked? Here we called what is LangGraph. And from here, it went to the decide underscore search node. So on decide underscore search node, it went through these conditions, okay? And because we are having LangGraph in our question, then it will return the search type as RAG. So now if you see the conditional edges, here we had this decide search. Now decide search return the RAG. So now a router will try to find out the mapping for RAG, which is PG vector. So in this case, it will call the PG vector node, okay? And after PG vector, it will call the PG vector answer. So from PG vector node, it will call the tool node. So this is the PG vector node and it will call the tool node. It will retrieve the result. It will store the result in the documents and then the answer node will come and this answer node will return the response in the answered field. Okay. And this is what we are doing after getting the result. We are fetching that particular result from the answer. Okay. Now let's talk about calculation. So 5 plus 2, if we try to execute this piece of code, then we should be getting the output as calculation result colon 7. See, we got the output calculate result colon 7. Okay. Now, after this, we require here this if the queue length is less than 3. So we are going to say simple thing cricket. Okay. Now it will not match to this condition and it will not match to this condition. And our length is less than 3 also. Then it will be going to this condition. It will go to the clarify and the clarify node will say provide more details so I can help accurately. See, it says please provide more details so I can help accurately. Now the last use case is the direct, which is this one. So if we say what is cricket, please explain. Okay. Now as soon as we provide this question, we don't have any mathematical operator. It will not call math. We don't have any keyword like RAG, search and vector. It will not go into that particular RAG thing. Now, it will also not be going to the clarify because the length of this question is greater than 3. So it will directly going to end the execution as is. So let's execute this piece of code. So you can see in the output, there is no node or the method got executed. It directly broke the flow because we mentioned if any condition did not get matched, then you will be directly ending the code. There is no node like calculator, PGVector, or clarify you are going to call. You will just end the code there itself. And this is how we can work with multi-AI path with LangGraph. Thanks for watching this video. Please don't forget to like and hit subscribe button. Have a good day. Bye-bye.